Now let's work on October 2019 Unit 1 paper. The first question here, which element is in the D block of the periodic table? So we're given 4 choices. We have argon, chlorine, iron, and sodium. So what are D block elements? D block elements are also called transition metals, which have their last electrons entering the D orbital. Now let's check if the given elements here are in the D block of the periodic table. So argon, Ar, this ends in 3p6, and this is in the P block. Okay, so you need to know the right electronic configuration of each of the elements. Chlorine ends in 3p5, chlorine or Cl. So that means chlorine is in the P block. Then iron, Fe, this ends in 3d6, 4s2. So iron is in the D block. Then sodium ends in 3s1. So this one is in the S block. So among the choices here, iron belongs to the D block of the periodic table. So iron is a D block element. All right, we're on number 2. What is the equation for the third ionization energy of aluminum? So what is the third ionization energy? The third ionization energy refers to the energy needed to remove one electron from a doubly charged ion. In this case, we're given aluminum, so we'll take a look at aluminum 2 plus. And ionization energies are always measured for gaseous atoms or ions to avoid interference from bonding forces. So let's write the equation for the third ionization energy of aluminum. So it would start with aluminum plus 2 charge, then aluminum plus 3 or 3 plus, gas plus 1 electron here. So we remove 1 electron. Therefore, the answer here for number 2 is letter C. Eliza, we'll just discuss the calculations first. All right, the problem solving. So we skip 3, 4, and 5. Okay, those are not calculations. So we start with number 6. What is the relative formula mass of hydrated ammonium iron 2 sulfate? Okay, given the molar masses of each of the elements. So we're given here ammonium, hydrated ammonium iron 2 sulfate. FeSO4, 2, and then water. So we're given the molar masses of each of the elements. Then we need to solve for the relative formula mass. Now to solve for the relative formula mass, we just have to multiply the number of atoms and the molar masses of each of the elements. So this is just, okay, we have, how many hydrogens we have here? Sorry, I forgot. It should be NH4 2 FeSO4 2 and 6 molecules of water. So from NH4 2, we have 2 atoms of hydrogen. So that would be 2 times 14 grams per mole plus hydrogen. Okay, hydrogen we got 8 from ammonium and then 12 from water. So that is a total of 20 atoms of hydrogen. So that is 20 times 1.0, because 1.0 is the molar mass of hydrogen, plus iron. How many atoms of iron do we have here? We only have 1. So that is 1 times the molar mass of iron, plus sulfur. We have 2 atoms of sulfur times its molar mass, plus oxygen. So we have 8 and 6. So there's a total of 14 atoms of oxygen times its molar mass. Then we calculate this, we add them up, then add them up. This would give us a relative formula mass, which is equal to 392. So the answer here in number 6 is letter D. Now let's answer number 7. How many atoms are there in 36 grams of water? So we're given here 36 grams of water, and we need to find the number of atoms of water. And we're given the Avogadro's number or constant, which is 6.02 times 10 to the 23rd per mole. We get the molar mass of water first. So molar mass of water, so that is 2 times the molar mass of hydrogen plus the molar mass of oxygen. So this is just 18.0 grams per mole. And then we get the number of moles of water. So we're given 36.0 grams of water. We divide that by its molar mass. Okay. And the gram unit here cancels out. So 36 divided by 18, so this is 2 moles of water, or molecules of water. So we need to convert that first to moles. I meant from moles to molecules. So we convert moles of water to molecules of water, and then we convert that to atoms. So that is 2.0 moles of water times 6.02 times 10 to the 23rd molecules per 1 mole of water. So this is just 1.204 times 10 to the 24th molecules of water. But in the problem, we are asked for the number of atoms per molecule of water. So number of atoms, we start from there. Each molecule of water here, we have 3 atoms. So 2 atoms of hydrogen and 1 atom of oxygen. So we just have to multiply 1.204 times 10 to the 24th molecules times 3 atoms per 1 molecule of water. So this would give us 3.612 3.612 times 10 to the 24th atoms of water. So this is our final answer. So That would be the answer for number 7 is letter D. Right, now let's answer number 9. Let's just skip number 8. So number 9, in which pair are the ions isoelectronic? So we're given here 4 pairs. 4 pairs of ions. Okay. The first one is calcium and sulfur. Then we have potassium and bromine ion. Then we have lithium ion and fluorine ion. Then magnesium and chlorine ion. But first, what is an isoelectronic? So isoelectronic means having the same number of electrons. So let's check each pair in the choices here. So we have calcium ion plus 2. So we calculate the number of electrons here. So this is just, the atomic number of calcium is 20 minus the charge, because it's positive, it's a cation, so it loses electrons. So we subtract that, 20 minus 2, so it has 18 electrons. And how about sulfur? It gains electrons, and sulfur's atomic number is 16, so that is 16 plus 2, that is equal to 18. So notice here they have the same number of electrons. So letter A, calcium and sulfur ions could be the isoelectronic. But let's check the other pairs first. So for potassium, that is 19. Okay, 19 minus 1, which is 18. And then for the bromine, that is 35 plus 1, which is equal to 36. So potassium and bromine aren't isoelectronic. How about lithium and fluorine ions? So lithium is 3 minus 1 is equal to 2. Fluorine is 9 plus 1 equals 10. They're not equal. Okay. So it cannot be lithium and fluorine ions. Then how about magnesium? Magnesium is 12 minus 2. Then chlorine, that is 17 plus 1 equals 18. They are not equal, so cannot be magnesium and chlorine ions. Therefore, the answer here in number 9 is letter A. So calcium and sulfur ions here are the isoelectronic pair, because they both have 18 electrons, the same as argon. Now let's skip the rest of the numbers. We'll do the calculations first. So we solve number 13 first. What is the atomic economy by mass for the formation of iron in this reaction? So we are asked for the atom economy by mass. And we're given this formation of iron. So Fe2O3 plus 3 carbon monoxide, then produces iron and 3 carbon dioxide. And we're given here the molar masses of each of the elements. Oxygen, then iron. Now the first thing we do here is we check the chemical equation or reaction, whether it is balanced. So we need to write a balanced equation first. So we have 2 iron here on the left as well as on the right. Oxygen is 3. Oxygen here is 6. We have another oxygen here from carbon monoxide, so that is 6. And then carbon is 3. Okay, so that means the given equation is already balanced. And now we calculate for the molar masses. The molar masses of the desired product and the total mass of the reactants. Since atom economy is just equal to the mass of desired product divided by the total mass of reactants times 100%. So we can, okay, we get the mass of the desired product first, which is iron. We do like this so it won't be confusing. So 2 moles of iron times 55.8 grams iron per 1 mole of iron. Then we get the mass of iron, which is 111.6 grams. And then for the total masses of the reactants, we just need to get the mass of each one. The reactants here are Fe2O3 and 3 carbon monoxide. So we start from here, iron. Okay, total mass of reactants. This is just 2 times the molar mass of iron, which is 55.8, plus 3 times the molar mass of oxygen, which is 16, plus 3 times the molar mass of carbon, which is 12, plus 3 times the molar mass of oxygen again. So this gives us a total mass of 243.6 grams. And now we can solve for the atom economy. So this is just equal to 111.6 grams iron divided by 243.6 grams of reactants times 100%. Calculating that would give us 45.8%. So this is the atom economy of iron. So the answer here should be letter B. So the answer is letter B. Now let's move to number 14. It's another calculation. A 2 kilogram sample of water contains 40 parts per million by mass of nitrate ions. What is the mass in grams of nitrate ions in the sample? So we're given here 2 kilograms sample of water that contains 40 parts per million by mass nitrate ions. And then we are asked for the mass in grams of nitrate ions. Nitrate ions in the sample of water. So let's just write that as nitrate ions. Now first, what is ppm? Okay, parts per million by mass. So when we say 40 ppm by mass, this is just equal to 40 parts of solute per 1 million parts of solution by mass. Alright, so that means the mass of nitrate here, so this is just equivalent to the mass of nitrate divided by the mass of solution, which is 1 million. Now take note that we are asked to solve for the mass of nitrate ions in grams, but we're given a sample of 2 kilograms. So we need to convert 2 kilograms to grams. So we just multiply that by 1,000. So that is equivalent to 2,000 grams. All right, we already have the mass of the sample, and then we have the 40 grams mass of nitrate ion from the given 40 ppm parts per million by mass. Okay, so we just have to mass of nitrate. Okay, mass of nitrate ions, that is just equal to 40 ppm times 2,000 grams. Then we get 0.08 gram, or we can write this in scientific notation, since the choices we don't have 0.08, then we need to convert this to scientific notation. So this is, or we write to as a scientific notation. So this is 8 times 10 to the negative 2 grams nitrate ions. So this is our answer here. So from the paper, the answer should be letter A. Now let's move to the next problem, number 15. Okay, a sample of hydrated calcium sulfate. So this is hydrated calcium sulfate was heated to constant mass. 3.405 grams of anhydrous calcium sulfate. So we're given here 3.405 grams of anhydrous calcium sulfate and 0.900 gram of water. Okay, 3.405 grams of anhydrous calcium sulfate and 0.9 gram of water were formed. What is the value of X? Oh, it should be X here. This one. So what is the value of X here? Okay, we're given the relative formula. So relative formula mass is equal to, this is for calcium sulfate. This is 136.2. Now we solve for the value of X, the multiplier here. All right. So now let's solve this. We're given the mass of anhydrous calcium sulfate, and we're also given the mass of water. So we need the molar masses of each of this. So molar mass of calcium sulfate, that is just 1 times the calcium plus 1 times sulfur times, no, plus 4 times oxygen. So this is just 136.2 grams per mole. And then molar mass of water, that is 18.0 grams per mole. So we need to find X here in this sample of hydrated calcium sulfate. So this is what we're going to do. We get the number of moles of calcium sulfate and as well as the number of moles of water, and then we get the ratio between them. Then that is the value of X. So moles of calcium sulfate, that is just the given mass, which is 3.405 grams, divided by the molar mass, which is 136.2 grams per mole. So this is just 0.0250 mole. And then for the number of moles of water, this is just 0.9, the given mass here, 900 gram, divided by the molar mass of water, which is 18. So this gives us 0.0500 moles of water. Right. So we divide this by, or we get the ratio of water is to calcium sulfate. So this is just 0.050 is to 0.0250. So we divide that. You can just do like the 0.0500 divided by 0.0250. And then we get 2. So x here, therefore x is equal to 2. So from the paper, the answer should be letter B. Now let's answer number 16. During a cracking reaction, each molecule of an alkane with formula C10H22 formed only 2 molecules of formed only 2 molecules of ethene and 1 molecule of hydrocarbon A. What is the molecular formula of A? So let me read it again. During a cracking reaction, each molecule of an alkane with formula C10H22 formed only 2 molecules of ethene and 1 molecule of hydrocarbon A. What is the molecular formula of A? Alright, so originally, we're given here, or the original alkane's formula is C10H22, and the products are 2 molecules of ethene. Ethene is C2H4. Then 1 molecule of hydrocarbon A. So we need to write the reaction in general form. So that is C10H22. Then this formed 2 ethene, 2 molecules of ethene, and 1 molecule of hydrocarbon A. Now to find the molecular formula of A, we need to count the number of atoms of each of the elements from both sides. So let's start with the elements on the left side of the reaction. So in the left side, we have 10 carbons, and then we have 22 hydrogen. We can just put them together, put all of the carbons together, then put all of the hydrogens together, so we can get the number of atoms for each of the elements. So on the left side, we have 10 carbons, and then we equate that to, we have 4 carbons here, 4 carbons, plus we don't know how many carbons the hydrocarbon A has. So we can just denote carbon of hydrocarbon A. And then on the right side, this is the right side, so the number of carbons on the right side. So we have 4 carbons plus the number of carbons in the given hydrocarbon A. So this is the right side. And for hydrogen, we count the hydrogen atoms. On the left side, there are 22 hydrogens, and then on the right side we have 8 hydrogens, plus we don't know the number of hydrogens in the hydrocarbon A. Right, from these given two equations that we've formulated, we can calculate the number of carbon atoms from this equation, and the number of hydrogen atoms from the other equation. So that would be 10 equals 4 plus carbon atoms of hydrocarbon. Then we subtract 4 from both sides. Therefore, the number of carbon atoms in the hydrogen carbon, or the hydrocarbon A, is 6. Then for hydrogen, that is 22, equals 8 plus the number of hydrogen atoms in hydrocarbon A. We subtract 8 from both sides. So the number of hydrogen atoms there is 22 minus 8, and that is 14. Therefore, hydrocarbon A's molecular formula is C6H14. So the answer here is letter B.